Hi guys, good evening and welcome back to the continuation of our project. So this is the part 2 of unveiling the water crisis in Maji Ndogo. So without wasting much time, let's just delve deep into our data or our information we have. So to begin with, we'll have to clean our data. So we have to bring up the employee table, which has info on all the workers, but we should note that the email addresses have not been added. We'll have to send them reports and figures, so let's update it. Luckily, the emails of our departments are easy, so the format is in first name dot last name at ndogowater.gov. We have a guide here that is going to take us through. So we'll have to select the employee name column. We will replace the space with a full stop. We will make it a lowercase and then stitch it all together. So let's go into our workbench and work on doing that. This is a walkthrough, yes, but I'd like to expedite things. I have already worked on this, and the codes that I used in the earlier one, I saved them, so I'll just be copying and pasting them without typing, because the typing usually takes a lot of time, so that we'll be able to cover quite a lot within a shorter space. So for this first one, I'll just walk it through. So first, let's select everything from the employee table. Employee. Right. So this is it. Now the email section is null, and we have to update it using the employee name together with at ndogowater.gov. So first off, we have to select the employee name column. Let's change this to employee name. Right. Now the next thing we'll have to do is to replace the space with a full stop. So replace employee name. What are we replacing? We are replacing the space with a full stop. Right. So let me do this rather. Okay. Right. So let's set this as updated employee name, updated employee name. Right. So this is how it looks like. Okay. Now next, we are supposed to make it a lowercase. So in this same function, we will just wrap what we just worked on with our lowercase, then we execute. Okay, so we realize that over here everything has changed to a lowercase, and then the last thing we'll do is to stitch it together. So from our slide deck, or the modules that we went through not too long ago, to combine strings together, we'll use the concat function. So concat, we are concatenating all of these, and then we are concatenating it with at what's the email domain, ndogowater.gov. Right, and let's close this bracket, and let's run the query. Right, so this is how it looks like. And this is, let's change it to employee email. Let's change the name of the column to employee email. Right, now this is how it looks like. Okay, now the next thing is we have to update the actual table. Okay, but we already know that to update it, we are supposed to create a copy of the table, right? So let's create table. So the table's name is employee, and then we'll set is it employee email? Let me take a sneak peek here. So we'll set email no I'm a bit confused. So we are creating a table. Now we'll create the table as, so we'll select, so the table's name, sorry, is employee copy. We'll select from the employee table, right? So unknown column, okay, let me include the database MD water service. This, we are using the copy version. Okay. Oh, the mistake I keep making, we select everything from employee. So let me take this out and see if that will work. Yeah, it worked. So let me refresh it. I have employee copy, right? So let's update the email in there and see how it will look like. Okay, so we are updating the employee table, or in this case employee copy. Then we will set email to, let's copy everything here. Paste it where email is now, or we can just run it this way. So why do I have an error? Okay, so let me just run it this way. So there was an error. So select employee. Okay, we've already run this. You see, these are some of the reasons why I don't like to use the semicolon, because it will have to run everything again, right? So you let me take that one out. Let me update my employee copy. Let's see how it comes out. Okay, so it's been updated, right? Now let's see how our table will look like. So let's select everything from the employee copy table. So employee copy, and let's see how it looks like. Good. So now our email section under the employee table has been updated. So let's do the same thing in the actual table. But before that, let me drop the employee copy. So let me drop table employee copy. Okay. Okay. Yeah. So this is the original table. Now I'll also edit this and I'll take the employee copy. I've already dropped this, so I'll have to take it out. If not, we'll be getting a series of errors. Right. So after updating the table, this is how it looks like. Okay. All right. So we are through with this part. So these are the guidelines we were given to work with. Okay. So moving on, I picked up another bit we have to clean up. Often when databases are created and updated, or information is collected from different sources, errors creep in. For example, if you look at the phone numbers in the phone number column, the values are stored as strings, right? So looking at where is our table employee, looking at phone number, instead of an integer, they are stored as variable character. But I think this was because of the plus, because if the plus because of the plus, it was set as a variable character. If not, there will be an error, right? So the phone numbers should be 12 characters long, consisting of the plus sign, area code, and the phone number digits. However, when we use the length column function, it returns 13 characters, indicating there's an extra character. So let's do that and see. So let me do this. Let's see the length of the phone number, right? So phone number, and then that should come out as let me just make it length. So let's run it and see. Right, so we have the length as 13 here, right, as it has been indicated. So it returns 13 characters, indicating there's an extra character. So that is because there's a space at the end of the number. If you try to send an automated SMS to that number, it will fail. This happens so often that they create a function especially for trimming off the space called trim. So that is the next thing we are going to do. Right now, we already have this query in here. So what we are going to do is we could put the trim before the length and then our argument. Okay, but in this case, we want the trim to rather affect the argument before we count the length or the number of, should I say, letters or characters. Okay, so if we should do it this way, if we should trim it this way, we are not going to get the result we want because the trim is on the length and the length is on the phone number. So the length is a preceding, the length is acting on the phone number first before the trim acts on the length of the phone number, which is not ideal, right? So what we'll do here is we'll rather trim the phone number, right? So that after the trim, then we count the length of it. Okay, so let's execute this and see what happens, right? So we now have the length to be 12 because we've trimmed the extra space that is after the phone number. Aside trim, we could as well use R trim, and that will also work perfectly because R trim trims from the right back. So any extra number or space after the last number will be trimmed. Let's use L trim and see what the effect will be. When we use L trim, we get 13 back because L trim trims from the left side coming in, right? So in this case, we can use trim or R trim to get a result we want. Okay, so let's move on. So the trim column removes any leading or trailing spaces from a string. So as we've already done, we used trim to write the select query, and then we make sure we get the string without a space. Then we have to now update the record like we did for the email. Okay, so what we are coming to do now is to update this and include, we make sure that the phone number is without any space as it was before. Okay, so what we are coming to do now is with this same, let me copy this updates command that we have. In this case, we are updating phone number, so set phone number to this. This is the function we use to trim. Okay, so set the phone number to all this function. Let's paste it, right? And then let's run it. Bravo. So even now, if we should remove this trim function and count or just find the length, it should come out as 12. Let's try and see. So let me just remove this trim function, right? Let me remove the extra bracket and run it. Oh, the updates worked. Oh no, I should have removed the updates. No. Our data is compromised, so I need to do this all over again. Oh, that's bad. So what I am going to do now is phone number. I can't undo this. Oh, gracious me. This is hell. Oh, okay. So I think I have to start all over again, right? So what I'm going to do is let me import in a new database. I'll copy all these functions that we've already run here up to a point so that we'll be up to speed. So I'll remove the extra. I'm just adding copy so that we know that we are working with a copy. If not, it will remove the original one that I am working with, which will actually put me in a lot of okay, so yes, I'm going to run this and we are going to do away with the old one, then we work with a new one, right? So I just executed it. Let's wait for a while. Okay, here we are now. So let me use my MD Water Services copy just to be sure that I don't have any issues with the original one. Okay, so now I'll come here and then I'll copy everything up until this point here, right? Let me copy all this and paste it here. Okay, now let me execute. All right. So okay, this is just for the first one, and then okay, so let me delete this, or better still, let me trim, and then oh so let me open the brackets. Yeah, let me copy this as well and put it here. Guys, apologies for this, right? I made a terrible error, so I had to correct everything, and then here we are. Okay, so the next thing is we are going to update our employee table. Okay, this I can't work with this anymore because I have dropped this one. So this is the new one. Once I am done, I'll close the old one. So let me execute. Right, we have it. So I'm going to do away with this because I don't need it at this point. If not, I might have issues. Okay, so what I was trying to do was, after we've updated this, we don't need, I was just trying to select everything in here with a length so that we'll know that after updating, we will have the length as 12, meaning the space has been taken out. But the error I did was I didn't take out this update function, so it changed what we had already worked on. So I'll take it out. Then I'll take out the trim because we've already trimmed it, and then I'll run this query. Okay, and it should return 12 because the space has been removed. So run. Same mistake. Well, I guess I don't have to even do it because I don't understand why. Oh no. Is it because of this update? Is it because of that? Oh. Damn it. I need to do this again. Guys, I'll forward this part of the video so that we don't waste much time. Let me speed all of this up. Copy. And then another copy. Let me execute. Right, done. So use the bunch of services. Good. Now let me copy everything in. Okay, so as we've gotten it, let me just update it and then we'll move on. I want to do it again so that we face those issues, right? So I'm going to update phone number with this. And we should be fine. Good. So we have it. Let's move on. I'm not going to do any changes again. So we are done with the update. The next thing is to honor the workers. We are coming to honor them. Before we dive into the analysis, let's get you warmed up a bit. Let's have a look at where our employees live. So we use the employee table and count the number and count how many of our employees live in each town. Okay. So as I said, I already have the function for that. So let me remove this because this update function is I don't really trust them. The least we do, we will mess up our data. So I don't really trust them. Let me just take it up. Right. So now going on, yes, we are to count how many of our employees live in each town. So first off, let's okay, we already have our employee table here, and then where they live, the town they live, right? Okay, so we need to count. Okay, first off, let's select everything. Then we will count. Also, we can count everything in here, right? We can count everything in the table. as should we make it total number of employees or something? So as number of employees, number of employees. Okay, let me put a comma here. As number of employees, and then you can run it. So from the MD, no, this is the employee table. Okay, when we run this, it should work. Okay, so what at all is happening to this data? So we have to group by town name. Yeah. What did I do wrong? Because this thing is, you know what? Let me do it this way. I'm even tired of all of this. So we are selecting everything, counting the number of employees, and then we group them by town name. What's that? Group by is non-aggregated. Okay, let me be specific. I am counting employee name. Okay, let me run it. This should work. Oh, so town name should work, right? Okay, yes. We only wanted the town name, and the reason why it wasn't the rest queries coming up, because once using the group by, it will sum up everything. So it couldn't sum up the rest of the data because there were other values in there, right? So we've been able to find the places our employees live, the towns they live. Okay, so the next thing is for us to note how many of our workers are living in smaller communities, right? So Yaoundé, Harare, Kintampo, Lusaka, Zanzibar, and is it Ilanga? Yeah, these, and then we have majority living in the rural areas. So President Naledi congratulated the team for completing the survey, but we would not have these data were it not for our field workers. So let's gather some data. Let's move on. Okay. So next we are going to look at the number of records each employee collected. Okay. Now, so we have to find the table, figure out what function was used and how to group them. I'll just be a bit snappy about this. Okay. So this is the table that, this is the query that I used for that. Okay, so we are finding the records for each employee. Okay, so we are going to select, I can remove that distance, it doesn't make any difference. We'll select the assigned employee ID. We count their visits as number of visits from our visits table. Right, so let me run this query and let's see what happens. Okay, now let me just explain this. There's a limitation if I do the copy and paste, but then usually if I walk through, it gives more understanding. Okay, so we selected already the assigned employee ID, and then we counted their visits. Let me remove this limits first. In fact, let me start all over. I think that would actually help. Okay, so first off, let me select what's the name? Assigned employee ID. Assigned employee ID. We'll select this from the employee table. So this is how it looks like, just the ID. Okay, but we are supposed to we can add a visit count to this. So this is how it looks like. Okay, so it has even given us what we are looking for. Okay, right, but we didn't even sum, we didn't count anything. All right, so what we are going to do now is, why am I getting this? This was the for the previous one. Visit count actually. So select assign employee ID and visit count. Assigned employee ID and then visit count. Okay, so this is what we get here. Right now, we want to aggregate it. We want to find what each person did, each employee did. Right, so we're going to count the visit count, and we'll use that. We'll create that as let's count visits count, and we'll name that as number of visits. Right, then let's group it by assign employee ID. Now we are grouping it because it's an aggregated function, right? So group by assign employee ID. So let's group this and see what we get. Contains non-aggregated, so okay, then let me remove the visit count. Okay, so this is how it looks like. Now let's limit it to 3, right? But now we want to see the highest, I mean those who recorded the highest. Okay, so let's we'll order by the number of visits. We want to sort them out in that order. So the highest person followed by the second highest and then the third highest, right? So let's order by number of visits right? Now let's run it again. So okay, we want it from the highest to the lowest, right? So in the descending order, right? So this is how it looks like. Okay, now the first person recorded 3,708 visits, and then it's followed in that order. Okay, so this is different because with ours we sorted it based on whoever recorded the highest number. If we should remove the sort, or the what's the name, order by, is going to look exactly as it is here, right? but we've been told to only see the top 3 employee IDs with the highest number of locations visited. So this is how it's going to look like. Okay, now this is it, right? So we are done with this. So it says we should make a note of the top 3 assigned employee ID and use them to create a query that looks up to the employee info. Since we are pro at finding stuff in the database, we can figure this one out. So we should have a column of names, email addresses, and phone numbers for our top dogs, right? So for our top dogs, so for our top dogs, we are going to, we need just 3 items, right? So let's select, we have employee name, so employee name, email address, and phone numbers. So employee name, phone numbers, then email addresses. Or let me bring the email first before the phone numbers. Email and then phone numbers. Okay, so but then we have specifics, right? So we want the top 3 where assigned employee ID is equal to, the first one is 1 from this row. The first one is 1, the second is 30, the third is 34, right? So 1, or let me copy everything here and then we'll just do a little editing. Or the next one is 30 and the third is 34. So 30 and then, or the next one is 34, right? So okay, so once I run this is what we get. So the phone number is as a result of the error we had in the first table. So kindly pardon me if we should work it out right. This shouldn't be there. Okay, so the phone number, if I should select it from here, let me copy this same one and then I'll select MD Water Services, the first one. Okay, if I should run this, we'll have the actual phone numbers. But because of the error I made earlier, that is why I don't want to go back over that. I've been through that 3 times already and it's taking more of our time. So this is how it's supposed to look like. And I haven't updated this, so the email column is still now, right? So but here we have updated the email, so we have the email and then we have the phone number. Okay, so let's move on. Let me close this. Okay, so we are done with this part. We found our top docs. So let's move on to the next one. We have to record, count the number of records per town. So looking at the location table, let's focus on the province name, town name, and location type to understand where the water sources are in Majindogo. So let's this is Analyzing location. Let me analyzing location. So let's select province name, town name, location type. So we are using location. Okay. So yeah, there's a province name, there's our town name, and there's our location type. Okay. So what we are coming to do now is we have to query, create a query that counts the number of records per town. Okay. So records per this, records per all the towns in here. Okay. So let me make it records per town. All right. So with records per town, first let's select the town name. We'll select the town name from, oh sorry, let me close this. We'll select the town name from location. So we're going to count the town name. Ouch. Let's count town name as records per town. Records per town, right? Then bring a comma here. Then we'll group it by the town name. Okay. We can do this, and then later on we can order it. Let's order it in a descending order. We want the highest to the lowest. So order by, let's still do records per town. I want to order it by this in the descending order. Records per town in the descending order. Okay. So yeah. So we have the highest, the next highest, and in that order. Okay. Okay. So we are done with this part. So now we should do also then count the number of records per province. So let me copy everything in here. So records per province. Right. So instead of town name, we'll select province name, and then so we'll select province name, and then we'll count province name, change it as records per province. So province name, so record per province. Let's do it. Okay, and then we'll still select it from location, and then we'll group by province name, and then we'll also order it by. So in effect, we are just replicating what we did earlier on. So this will be records per province. Okay. So when we do this, we can execute, and then we are good to go. Right. So these are also the records per province. Okay, we only have 5 provinces. So we are done with that part. Right. Now let's move on. So from this table, it is pretty clear that most of the water sources in the survey are situated in small rural communities. Okay, scattered across Majinogo. If we count the records for each province, most of them have a similar number of sources. So every province is well presented in the survey. Okay, so the next thing we have to do is to find the following. We have to create a result showing the province name and then town name, and then we will aggregate it by counting the records for each town. Then this is the town name, and then we'll group by province name and town name, right? Okay, so let's see how we'll be able to do this. So I'm going to count records for each town, right? So I'll count the records for each town. Yeah, so records for each town. Okay, so let's select. Let me have a look at this. So province name and town name. Province name. Okay, there's an error. I'll go and change that. Town name. Hey. So province name and then town name from store location. Okay. So the next we'll do is we are coming to count. So with this, let's count everything, right? And I'll explain. So we'll count everything as records per town. And then we are supposed to group by province name and town name. So group by province name, town name. Let's execute this and see what happens. Okay, right. So we should order our results primarily by province name. Okay. Within each province, and then we should further sort the town by the records count in the descending order. So let's order this by province name first, and let me execute it and see. Okay, so we ordered it by province name, and then we have to also order it by their record count. Okay, so and then records per town. Okay, so records per town in the descending order. Oh, somewhere. Okay, so this is how it looks like, right? So in the descending order, we have okay, so it's been grouped first by province and town name. So this is the town name, there's the province name, there's the town name. So in Akachi, we have rural, Lusaka, Harare, Kintampo, and then in Amanzi, we also have the same thing. So it's been grouped by in both and then sorted based on records per town, right? So the next we are going to work on is to look at the number of records for each location type. Okay, so number of records for each location type. Let me do it this way. Number of records for each location type. Okay. These results show us that our field surveyors did an excellent job of documenting the status of our country's water crisis. Every province and town has many documented sources. This makes me confident that the data we have is reliable enough to base our decisions on. This is an insight we can use to communicate data integrity. So let's make a note of that. All right. So in finding a number of records for each location type, let's first select location type from the location table. Okay, so right, we have urban, I believe it's urban and rural. Okay, so once we are done, let's count the location type as should we name it number of sources, or well, yeah, I think that one can do. So let's count location type number of sources. So count location type as number of sources, and then since it's aggregated, let's group by maybe location type. Okay, let's see what comes out. All right, good. So we have urban and then we have rural. Okay, now the next thing is we can see that there are more rural sources than urban, but it's really hard to understand those numbers. Percentages are more relatable. If we use SQL as a very overpowered calculator, we can input this and then we get this percentage. Maybe we can try. Let's let me call it percentage of, is it rural over urban? Yeah, rural over urban. So let's select rural is 23740 all over the summation of the two, 15190 plus 23740. Then let's multiply it by 100. Okay, so how should I call that? Let's say as ECT, and let me call it urban. Okay, so maybe should I round it? Let me just round it. Okay, so it's actually 61%, right? So we can see that 60% of all our water sources in the data set are in rural communities. So again, what are some of the insights we gained from the location table? Our entire country was properly canvassed and our data set represents the situation on the ground. Purpose, 60% of our water sources are in rural communities. We need to keep this in mind when making decisions. So we are done also with one part of our data. Moving on, we are diving into the sources. So water source is a very big table with lots of stories to tell. Before you go and spoil it, open up the table, look at the various columns and make some notes on what we can do with them and go ahead and make. So let's open up the water source table and see what we have there. So this is our water source table, right? We have a source ID, type of water source, and the number of people served. Okay. So the way I look at this table, we have access to different water source types and a number of people using each source. These are the questions that I am curious about. How many people did we survey in total? So we need to find the total number of people. Is this, yeah, surveyed. So so total number of people surveyed, right? So you can just select everything. Yeah. So let's select everything and then we'll sum number of people served. Served as, how should we even call it? Total number of people served. Okay. So total number of people served, right? So from our water source table. Okay, so we got an error. Yeah, because we are grouping by, you actually need to only select one. So let me run it this way. Just get a small table at the top here. These are the total number of people that we've served. So 27,628,140, right? How many wells, taps, and rivers are there? Okay, so how many wells, taps, and rivers are there? So let me see how we can do this. So let me wells, taps, and rivers. So wells, taps, and rivers, right? So let's select the type of water source. You're selecting it from our water source table. Okay. Right, these are the type of water sources we have. And let's count. Let's see if we can count. Let's try out the count function because we have to, how many wells, right? So let's count the type of water sources. Type of water sources. Let's call that as maybe number of sources. Number of sources, right? So let's group it by the type of water source. Group by type of water source. Let's execute and see how it goes. Okay, there's an error somewhere. Unknown column type of water source is supposed to be type of water source. Okay, let's run it again. Right, so this is what we got. Yeah, these are the 5 type of water sources. And how many taps? How many wells, taps, and rivers are there? So we have well, taps, and rivers, right? Okay. So let's see. Okay, right. Now, how many people share particular type of water sources on average? On average. So how many people share? So now to find the average number of people served, right? Or the number of people that share, the average number of people that share a particular type of water source. Let me make it like average number of people sharing a particular type of water source, sharing a particular type of water source. So first, let's select the water source from the water source table. Select water type of water source, I mean. So let's select type of water source from the water source table. Okay, I think this we did at the top. We know how that looks like. Let's go on. Now we'll find the average number of people. Let's find the average for the number of people served. Number of, okay, for us to have an idea, let me just execute this. Let's see what the table looks like. So no, let me make this everything first. So we have source ID, type of water source, and number of people served, right? So first off, we are selecting the type of water source, then we'll find the average of the number of people served. Okay, right. So let's select type of water source. Okay, now we are finding the average on the number of people served here. Number of people served. We'll name that as average. Let me call it average people, or average number of the people per source. Okay, so then let's group it by maybe type of water source. I think that will do. So group by type of water source. Okay, now once we execute it, all right, so these are the average number of people that share a particular type of water source. Okay, so how many people are getting water from each type of the water source? Okay, each type of the water source. So we've done this. This is the next one. So Which of those sources stands out? It's pretty clear that although there was a drought, water is still abundant. This isn't just an informative result. We will need these numbers to understand how much all of these repairs will cost. If we know how many taps we need to install, and we know how much it will cost to install them, we can calculate how much it will cost to solve the water crisis. So up next on question 3, as in the average number of people that are served, as we just did. So he said we should make it easy to read. So maybe we can actually round this up to the nearest whole number. We don't need any decimal, so that's will be very easy to read. Good. So there we have it. Right. Now the next thing to do, okay, this is what we just do. So these results are telling us that 644 people share a tap in home on average. Okay, so a tap in home on average, 644 people. So it says it doesn't make sense. The surveyors combined the data of many households together and added this as a single tap record, but each household actually has its own tap. In addition to there's an average of 6 people living in a home, so 6 people actually share one tap and not 644. It is always important to think about data. We tend to just analyze and calculate at the start of our careers, but the value we bring as data practitioners is in understanding the meaning of results or numbers and interpreting their meaning. Imagine we were presenting this to the president and all of the ministers, and one of them asks us, why does it say that 644 share a home tap? And we had no answer. Okay, so this means that one tap in home actually represents 64/6, that is plus or minus 100 taps. So calculating the average number of people served by a single instance of each water source type helps us understand the typical capacity or load on a single water source. This can help us decide which source should be repaired or upgraded based on the average impact of each upgrade. For example, wells don't seem to be a problem as fewer people are sharing them. On the other hand, 2,000 share a single public tap on average. We saw some of the queue last time, and now we can see why. So look at these results. So looking at these results, we probably should focus on improving shared taps first. Okay, I think this is just an information for us. Now, let's calculate the total number of people served by each type of water source in total. To make it easier to interpret, order them so that most people served by these sources are the top. Okay, so now we are coming to find the total number of people served by each type of water source, right? So total number of people served by each type of water source or in total. Okay, so let's see. This is what we got. Let's try and play around it to see what we can also get. So first, let's select let me select everything from the water source table. Okay, and here we have it. Now we are calculating the total number of water served, right? So let's okay, so we are summing the number of people served. Then we'll call that as population served or total population served. Total population served. Okay. Let's group it by maybe type of water source, right? I'm grouping it by type of water source. And then it says we should order them so that most people served by the sources at the top. So let's order. We are ordering by the population served. This. So total population served with the highest at the top, so in a descending order. Okay, when we run this, we'll have an error because we've grouped it. This is an aggregate function, so we need to actually specify what we want to calculate on, right? So we are selecting the type of water source. Let's select the type of water source. Now let's run it. Oh, dear Lord. Okay, so this is what we have. Okay, this is what we have here. We are grouping the type of water source, as we can see here, and then there's the total population served. Okay, so we can see here that share tap serves about 11,945,272, and then it's in that order. So tapping home serves less, river serves way lower, right? So we are done with this, as we can see here. It's a little hard to comprehend these numbers, but you can see that one of these is dominating. Yes, that's the share tap. To make it a bit simpler to interpret, let's use percentages. First, we need the total number of citizens, then use the result of that and divide each of the sum of the people served by that number. Then we'll multiply by 100 to get percentages. Let's take it one by one. Okay. So we've calculated this, but we need the percentage, right? Let me just so percentage per people per source. So total percentage per people per source. So let's select our data first. So let's select, we are using the data at the top here, but we'll adjust it a little bit. Water source from our water source table, right? So to close this, right? So we've selected from our water source table, right? Okay, so let's take it. It's a bit I don't want to use the word complicated, but let's take it a step at a time. Okay, so first off, we'll use what we calculated at the top here, right, to come up with the percentages that we want to find. Okay, right. So what we'll do is let's select everything up here. Okay, let me select all of this first. Let me place it here. Okay, so we're going to use the number of people served. Okay, this narration. Okay, we need the total number of citizens, then use the result of that and divide each by the sum of the people served. So the sum of the people served here, or in other words, the total population. Let me just make it that way. The total population, right? Okay. So we'll find. Let me take this one there because that is what we use to calculate the total population, right? So the sum of so it's going to be something like this. We'll have the population served, right? This is the population served, or the, let me say, total population served. So this is the total population served. We will divide it by the sum of the population. Okay. I'm trying to figure out how I worked around it. So let me see something. Let's select him. Let me see. Okay, let me bring another the population. Multiply it by 100 because you're finding it in percentages. Let's name that as percentage of people served, right? So yeah, dividing the total population by all of this, selecting the sum of the people served. Okay, so we are dividing this by the sum of the people served, and then we'll multiply it by 100 to get its percentage, right? This is becoming a bit technical for me. I've even forgotten how I worked around it. So let me see something. Select type of water source. I might face a little challenge here. I'm trying to figure out how I worked it. So in case we face any challenge, please pardon me for that. So let's do sum of the number of people served, all of this again, right? Sum, who's calling me at this time? The sum of the number of people served. Okay. Number of, sorry, people served. As population percent. by type of water source. So this is for this is for this is for this. I need to have another bracket here. Okay, so from water source, then let me order this by population. Order by population served. Something might not be right here. It's total population served in the descending order. Let me look through this again. Let me free hard. Error. There is an error somewhere. Error. Guys, I think once we get this right, I will break for now and then continue with the second parts later. I mean, with the other parts later. Right. So, function MD water services copy. Where is the copy from? Type of water source doesn't exist. Did I use MD water source? Water services copy. Type of water source doesn't exist. How? There's type of water source here. I already have type of water source, so why doesn't it exist? It was going to be tragic. So, total population served. All over, let's select the sum of the number of people served from the water source and multiply by 100. It's as percentage of people served. Okay, we'll select that from, and we'll select type of water source. We'll sum the number of people served. That's total population served. Okay, let me put total here. Total population served. From water source. Then we group by type of water source. Name it as totals. Followed by population served. Everything seems right to another error. Okay, let me do the wrong thing. Let me round this down. Okay. So round and around we go. So population served. Let's select some number of people served from water source. Two. 1, 2, 3. Let's see. Hey, what's wrong? Select sum of number of people served from water source, total number of people. Let me close this bracket here. Still not working. Still an error. Alright. Oh. Let me check what I did earlier. Where are you? So, what's our percentage by people? This is what I used. Let me just copy this and paste it in there. Let me make some few changes. So this is total population set. There's also total population set. Total population set. Like this. And then I remove this. This is becoming so tiring. Let me just execute this. If it works, I'll break it and then we'll continue later. Right, it worked. Okay, so I think maybe because of the previous one, we had some little errors. Okay, so guys, I'll break it off here and continue with the other parts of the project tomorrow, God willing. So please take your time and go through. For this last part, I didn't really do much narration because I think I'll have to go through again. But if in case anyone needs any assistance whatsoever, you can kindly reach out. Please take your time to go through to get the understanding. Thank you so much for your time, and we'll meet shortly.